Yo, I I was streaming Advent of Code Day 11. Now and I said I would stream me finishing it, but I finished it anyways because I didn't feel like streaming. And I also did Day 12, but now I want to stream Day 13. So here we are doing Advent of Code Day 13. I want to do all the days, but each problem is taking like at least a day to finish. So it'll probably take me like a few more weeks to finish it all, but I'll get there eventually. Alright, anyways, on to the problem. Day 13, distress signal. I've already set up my environment here. I did cargo add a cargo new D13, and then I added a color error because that's what Festive and Lime used. But now I'm here. Alright, so day 13, distress signal. You climb the hill and again try contacting the elves. However, you instead receive a signal you weren't expecting, a distress signal. Your handheld device must still not be working properly. The packets from the distress signal got decoded out of order. Jeez. Nothing goes right here. Gotta fix everything. You'll need to reorder the list of received packets to decode the message. The list consists of pairs of packets. Pairs are separated by a blank line. Okay. Okay, so in the example, this must be one pair. This is another pair. This is a third pair, and so on. Okay. You need to identify how many pairs of packets are in the right order. So packet data consists of lists and integers. So we have that there. Each list starts with um, open square bracket and ends with closed square bracket and contains zero more comma separated values, either integers or other lists. So I'm already thinking about using nom here and creating two structs, or maybe just one struct, a packet. A packet which could contain a vector of, probably we'll just call it a data type. A data type can be either a list or an integer. Or maybe it could just be a vector of integers. Unless if there are, yeah, no, that doesn't work. Because how do you disambiguate between just a normal integer and a vector of whose elements are just one integer? So that probably doesn't work. Um, yeah, we'll figure that out. Contains zero more, blah, blah, blah. Each packet is always a list and appears on its own line. And I see we have empty lists here as well. Then we can have nested empty lists. Oh, that's fun. When comparing two values, the first value is called left, and the second value is called right. So this is left, this is right, this is left, it's empty, right is a packet containing a single integer. Okay. If both pack values are integers, the lower integers should come first. Don't know what that means. If the left integer is lower than the right integer, okay. So, where is that the case here? It's not the case at all. Um, the inputs are in the right order. If the left integer is higher than the right integer, the inputs are not in the right order. Okay, so you would need to swap the packets in that case to have make the left become the right and the right become the left so that the left integer is higher than or is lower than the right integer. Otherwise, the inputs are the same integer. Continue checking the next part of the input. So if both of the values are lists, okay, so the first one was if both of them are integers, so that would be the case where I don't know. This is weird. Um, are we comparing like each element in the packets? No, because here the left packet has 3 elements in it, and the right packet has 4 of them. So I guess we'll just have to read on. If both of the values are lists, compare the first value of each list, then the second value, and so on. If the left list runs out of items first, the inputs are in the right order. If the right list runs out of items first, the inputs are not in the right order. I just realized that my stream settings, my broadcast settings are not right. How? Okay. I don't have YouTube open, so it's just gonna say the wrong title, so whatever. Um, okay, where am I? Oh, if the right list runs out of items first, the inputs are not in the right order. If the lists are the same length and no comparison it makes a decision about the order. Continue checking the next part of the input. If exactly one value is an integer, convert the integer to a list which contains the integer as its only value. Then retry the comparisons. For example, if comparing a list of 0, 0, 0 and 2, convert the right value to 2, a list containing 2. The result is then found by instead comparing the list containing 3 zeros and the list containing 2. Okay. So I think that would be good those rules are good to compare the order now. So in the first example we have, well actually, yeah, okay. If we compare element wise, we compare between the two lists element wise, okay. So here 1 and 1, it's inconclusive, so we move on to the next one. 1 and 1, inconclusive. The left is 3, the right is 5, which means it's in order because the left value is smaller than the right value. And do we continue from there? Okay, so yeah, we just stop right there. Okay. And then pair 2, we grab we pop the first element from each list. So we have a list of 1 and a list of 1. They're lists, so we compare the first value in each list. Oh, we compare element wise in that popped list. So it's 1 and 1. So same length, no comparison makes a decision. So we continue checking the next part of the input, which is a list containing 2, 3, 4, and then the integer 4. Okay, so since one of those values is an integer, then we would convert this to a list containing 4, and then we would check the first elements from this list, and then the list containing 4, which would be 2 and 4, and it's in the right order. So I'm assuming that in the right order, meaning 2 is less than 4. The left packet left packet is less than the right packet, which is what the theme was here. So I'm assuming this is in order, and we stop there. So let's check here. Yeah, compare 1 versus 1, inconclusive, 2, 3, 4 versus 4, mixed types, convert it to 4, retry comparison, 2 versus 4 left side. Okay, yeah, we do stop right there. Okay. And then on to the next one, we have a list containing 9 and a list containing a list of 8, 7, and 6. So we would turn this into a list. We would pop it out of that list. So we would take 9 and compare it with the first element from this list, which is 8. So 9 is greater than 8. So the packets are not in order then. So let's see. Mixed types. So yeah, so here compare these two. Mixed types converts. Retry comparison. Compare these two. Compare 9 versus 8. Smaller, so it's not in the right order. Okay. So here I'm assuming that where was it? I'm assuming because the left packet has fewer elements than the right packet, so they're all the same values except the right packet has one more integer in it. I'm assuming that means the left packet is quote unquote worse compared to the other one. So that means it's in order? Yes. Okay. That's right. Okay. And then the next one, so the left packet has more elements than the right. I'm gonna change my audio a little bit. I'm noticing that I'm peaking a little bit, so this should help a little bit. Maybe that's too low. Um, yeah, this seems good, I think. Maybe a little louder. Okay, I think that should be good. Where was I? All right. Since the left packet has more elements than the right packet, then it's comparatively better, which means it's out of order. So I'm assuming that if it's out of order, then that means the right packet should be the left packet, and the left packet should be the right packet. So they should be swapped, in other words. Um, yeah, this seems pretty straightforward so far. This one's an interesting case. There's no elements to compare. So how would you compare these two? I'm assuming that you compare the lists, and we would see that this list has one more element than the other list, so it's out of order because the length of this list is greater than the length of this list. So let's test that out here. Yeah, out of order. That's right. Okay. So I think I understand this now. What are the indices of the pairs that are already in the right order? The first pair has an index of 1, the second 2, and so on. In the above example, the pairs in the right order are 1, 2, 4, and 6. The sum of these indices is 13. Determine which pairs of packets are already in the right order. What is the sum of the indices of those pairs? Okay, this should be pretty straightforward so far. I'm not going to get the puzzle input right now. I'm just going to try to copy the example and then parse the example and then try to answer the puzzle question. So yeah, let's deal with parsing first. Okay, so first I already have my environment set up. It's my project directory, I guess. I'm going to create the example file. Let's copy paste that in there. And yeah, it should be good. So let's go back to our other buffer. I don't know why Rust Analyzer was complaining there. Okay. So yeah, let's have our inputs. We use the include stir macro. Okay, the LSB is upset. Okay, let's just do that. Turn OK. And then let's just restart the editor here. Let's go here. Let's cd into there, change that to our roots. And then this is the wrong day. Okay. cd here, go into the roots, open this. Okay. All right. So how would we parse this? Let's see. Okay. So we have everything revolves around this packet. And this packet just contains one element, I believe. Yeah, I was thinking about how would you determine left and right, but I think this is a good start for right here. So it's some kind of vector. What's the type of the vector? I think we'll need another data structure to be able to do this. Yeah, we'll need another data structure. So I'm thinking we use an enum here. So we have enum, let's just call it data, you know? And our data can either be an int, which will just contain in, well, is it, okay, it's an integer. They explicitly say integer. In our example, we just see use sizes, unsigned integers. But let's look at the puzzle input. I want to see if it's integers or if it's signed or unsigned. Nothing here is signed. Um, Not that I can see. So I'll just make it, I'll just make it signed anyways. And the other one is a do they call it list? Packet data contains a list and okay. Okay, it's the other one is a list, and this one is a vector of I32 as well. All right. And now our packets is a vector of data. Okay, cool. Now we want to parse this stuff. How would we do that? So I'm already thinking of using nom here. But could we get away with not using nom? I think we can. I'm also realizing that our list here can be empty, so it should be an option. Um, should I use nom? I mean, the input is simple enough where I don't think we can just try using to string or from string here. Type and let's just use report. So this I don't know what to do for that yet because I'm thinking we need to use we need to also implement from string for data. Okay. So here we could either get an integer or a list. So I think we try to let's something. So this variable will be s, and we try to parse it as an I32. So I think we'll try to match this, and maybe this will just be the return value. So if we get some I, which should be an I32, right? It's unknown. Why? Why? Anyways, I think if we get some I, or not some I, okay I, right? Since this returns in the results. Yep. If you get okay I, then we just return self int I. Okay. And then if we get an error, I don't really care what the error is. Here we try to parse it as a list. So we take s, um, first we try to match s, the first character of s. So s.cars.next. So So this should be an open bracket. So I guess if it's not an open bracket, then we just return an error. I don't know what to say here. Unexpected formats got you. Then we'll just pass in a string. Otherwise, maybe we should try to test the first string and test the last, or first test the first character and test the last character. So if s dot cars dot last, oops, last is not this. Okay. Turn that. But how would you handle recursion here? I guess you just have to call this method again. Okay, else, yeah, we just call this method, right? Self, or how would you even from stir? How would you call this again? Um, s dot into s dot parse. Parse, we use parse here. Parse into self. And then we return that. And maybe then we don't need to do this. Oh, this needs to be an okay. Okay. Does this make any sense? Comparison operators cannot be chained. I think I'm missing parentheses here. No. Expect this to be an option character. Oh, this is an option here. Oh, okay. Jeez. I guess we'll just expect. No, but that doesn't work uh, because I wanted to also output this same error. Okay, then what we can do is maybe dot like map or map or else repeats the default function results. Yeah. Okay, what do I want here? I think what I want is not to do this right here, but I want to map this So we take the character and then we compare the character to an open bracket. And so this way we get an option bool, and then now we want to say is okay, is sum. So in this case, if we do get a character, um, oh no, do we want to unwrap this? How about is sum and? Is sum and what is this? Is it bool? Sum and b. Yeah, that works. Does this return an option? It does, so we'll need to do the same thing. Also, I don't like next here. It's weird. Just do nth 0. So here we do the same thing. Take C, and if it's not this, then make sure it's sum and B. That way, if wait, what's going on here? C. Okay. Okay. Return incompatible types. Results data. Oh, they have to be what? Why is it expecting the unit type? Can I not return this from this arm? Also, this is weird. Um, okay, this is what I want. Um, you know what? Fuck this smash statement. Dot is sum is okay. Yeah, it's okay. Whatever. Or maybe let's let I equal. Can you do this? And then we can just um turn this. Don't know why that disappeared. Say screw that. Bring this out of the match statements. Does this work? Also, we have to return this. Matched type. Um, Pattern will always match. Eh. Oh, unreachable statement there. Irrefutable. This pattern will always match. What does that mean? Okay, let's just bring I out of that statement. Because I'm assuming it'll match on an error, which is weird, but whatever. And then we'll say if I dot is okay. Okay, that should be good. I want to cargo format this since this is indecipherable. Oh, forgot to source this even though I have set XRC on. Yep, it's on. It didn't. It says screw the vimrc file. Okay, let's see how this looks. Okay, this is a little more readable, I think. So this will. Let's just check the validity of this. So this will get the 0th character, and if it gets nothing, then it will just return false. Is sum will return false on none? Yes. Okay. And if it's sum B, then it will just pass through B. Okay, so this is the same thing here, so that should work. And now it doesn't matter if I have this returning or checking for brackets or not, but this is slightly more readable to me because it's kind of saying if we have a list, then parse the list recursively, but otherwise return an error. So now for the packet, basically what we want to do is unwrap this list. So how do we do that? I think we can do something like this. So this is our starting string. So let's say s equal s dot, sorry, s dot trim splits replace maybe. So what does replace take? A pattern. Okay, so I want to see how this replace works. There's probably a better way to do this, but whatever. Where we don't have to use replace, because technically all we have to do is turn this into a character iterator, skip the first one, and then collect into a string, which I will annotate this as a string. So this should work okay. And also let's just have to do just to shut up the Rust analyzer. Okay, so that works. And then maybe we can collect this as a character again. Okay, I guess we have to do explicit type annotations here. Dot cars. Yeah, cars. And then maybe we can reverse. um then skip the first character again. And then reverse again. And then collect. Why can't I collect here? Is this a string? Something's wrong. Okay, reverse. Um, yeah, don't know what that means. Oh, I called reverse already. Okay, so I'm assuming I have to collect again. Collect into a string. This is already messed up. Like, and then make into a character iterator again, and then reverse again, and then collect again. Isn't that the most messed up series of methods? Messed up chain of methods. So we turn it into a character iterator, skip the first character, so effectively this would eliminate so say we had something like this. This would eliminate this character to collect that into a string, and then we would reverse this, um, which would be something like this. And then what do we do? Reverse it, and then we skip the first character, and then we have to reverse it again. Oh my God. Okay. Skip the first one and then reverse it again to get our final our final string. That's not right. That's not right. I bet we could just take S, probably get a slice. How do we get a slice? Slice. So see stir and index. Yeah, let's just try this. And then the beginning will always be the second elements, and um the end will be s dot length -1. So if we had, for example, our input string this, then we would take the first element here. It says 1, 2, 3, 4, 5, 6, 7, 8, 9. So it says 9 characters in it. This would be index 8. So 9 minus 8 is this. So it would be from 1 to 8. Now, does it include the last? Is it inclusive? Including begin, but excluding end. So yeah, this works. 1, 2, 3, 4, 5, 6, 7, 8, 9. -1, which is 8. So we would exclude this, yeah. And then we would make this toString. And this is unsafe. This is unsafe. I've never worked with unsafe functions. Safe alternative use CSTR and index. Can I go there? No? well, this will have to be saved because I'm going to check for safety right now. So let's say if mm, if s.len length. So if it's less than 1, then if it's less than 2, we need it to be at least 2 elements. Then we will return an error. And then we'll say valid packet. Got this. I should prefix this. And then how do I convince Rust that this is safe? Okay, callers of this function are responsible that 3 preconditions are satisfied. Begin must not exceed end. Begin and end must be byte positions within the string slice. Begin and end must lie on UTF-8 sequence boundaries. Okay, so I've checked for this. I don't know if I've checked for this. How do I make sure that it lies on byte positions? And I don't know how to do this at all. Okay, so they have this example here. Um, okay, so they just take this string, and then they return all of it. Cool. Now we take this string and just take world out of it. Well, I know that for this application, this is completely fine. So, I don't know. Uh, okay, it's nice that they tell you what to use instead of uh what they tell you what to use in place of a deprecated function. Because I was looking for this, but all I can think of in terms of like how to find this kind of function is slice. I'm slicing the string. You know, I'm slicing the string. I'm removing the first character and the last character. I'm slicing it. But we can just use get unchecked, or we can just even use get in this case. I see. Oh, that's a lot better. And this takes one argument, which is a range I saw. So 1, 2, this. And just to make it clear, I can wrap this in parentheses. Apparently, this returns what? What does this return? An option. Um, okay. So I think I want to map this to results. How do I do that? So, or else? I forgot how to map an option to result. Okay, or else. Yes, okay. Um, Mapping some v to okv and none to error. Okay, okay, or else This closure doesn't take anything. Okay. Error. Um, what do I even put here? Something went wrong. I don't know. Got this. Okay, that should be good. Just look at an error. Um, oh, wait, this should be arranged, but it doesn't need to be parentheses. Okay. This is Rust Analyzer not knowing that the buffer changed. Okay, now we want to unwrap this with a with a with a question mark. I don't know what this question mark is called. Question mark operator Rust. What is it called? Just question mark? I mean, that's question mark operator. Okay. It's a very apt name. Oops. I just went out of that buffer. That means to. Okay. Here. All right. Source UMRC, and then please format this. I can't look at this anymore. Okay. Get okay or else toString. Cool. Maybe I don't even need to make it a string per se. Okay, so this is the string that we want, and maybe we should actually just make this say invalid packet. Okay, so now, so now we want to take S, we want to split it. Split it by commas, and then we want to map each element that we get, right? Yeah, so this first S was taking this slice out of the string. So the slice between the square brackets. And now we're splitting that, and we're mapping each of those elements so that each element E, which is a string, we turn that into some kind of data. So E dot E dot parse data, and this returns some results. Um, hmm. What if you get nothing? So this will have to be an option data. Um, I guess we map. No, we don't map the data. We want okay or. Oh no, we just want okay. Yeah, we just want okay. Because it'll map errors to none, which I did again. Oh my god. C. Okay, CV. CR. Okay. Um, that's okay. And then we want to collect this. Okay. Um, Yeah, let's try this, I guess. What does it say? Oh, like that, right? Okay, so, wait, what? What's going on here? Say okay. Type of the, oh, dear God, I'm stupid. Self. That's the okay self. Yes, okay, that works. This will not work. I There's so many edge cases that I didn't consider here. But let's just try to parse this anyways. Let's P equal okay, maybe take the input, split it at anything that has two new lines, and then we map that into a packet. Map each pair packets, so this should be string. Take each pair, we find the lines, um, and then we map each line so that we get packets. Parse it into a packet. And now we collect, does it know, um, so let's, packets equal that. Does it know, can it infer the type? No. Um, so this will just be a vector of packets. Uh, oh, I didn't collect over here. Dot collect. Actually, I don't even know what the type should be. Um, it's just some type. Okay, and then let's see if this works or if it just fails horrendously. Packet doesn't implement debug. Okay. Derive debug and then do the same thing for data because I know it'll complain about that. Try running this. Okay, source. Try running this. Thread main has overflowed its stack, and I know this has to do with this. So yeah, of course, because I didn't denote a base case for this recursive um control flow here. Okay. Um so if this and this, then this is why I should have used nom. This is why I should have used nom. I'm because handling this recursive case is annoying. It's a pain. But how would nom even handle like like knowing when to split the commas. Because if you just try to naively call um separated list and then just pass in a comma there, then it would return let's say you've already called delimited and delimited by this and this. Then it would return 1 and then this and then that, then this again. So I think Dom still has better tools to deal with this. So I just wasted a whole bunch of time trying to parse this stuff. Um, yeah. I still think everything here is good. I don't think I needed to make this an option data, to be honest. Yeah, I don't think I needed that. I just need to make an vec data. And then this, just delete that. It's useless. Same thing for this. Okay, now let's add nom. Cool. And now we'll just use impulse. And then just have a single function in here called parse, which takes our input, which is a reference to a string, and returns an I results. And of course, we need to import that. But I think REST Analyzer can do that for me. I results, which is the remaining input plus the result, which is self. Okay. And this we'll just figure out later. And then we'll do the same thing for packets. Okay. Does Rust Analyzer know what iResult is? No. Okay. We don't need this anymore. Use nom iResults. iResults. Okay. This is useless. Okay, so how would we parse this? Let's look at the base case for data. So data, a list can contain a list, which is an issue. So instead of, can we do this? Oh, oops, not that. Can we have the list take in a vector of data? Oh my God, we can. That is crazy. Recursive enums? Wait, really? No way. Let's try that out here. So we'll just have this to do here, and then we'll have a struct D, which takes in either, we'll do the same thing, int I32 or a list, which is a vector of D. And this is not struct, but an enum. Okay. And now we'll just debug, I guess. D, which is a list of a vector of D. Let's just say int 1, D int 2, D list, recursive list here of a vec of D int 3 and then D int 4. Let's try that. Does this compile? Yeah, let's derive debug here. Oh my God, it works. It works perfectly. In fact, yeah, that's it. Okay. Oh, that's crazy. Um, okay, so parsing. Okay, let's how do we do this? Okay, I know we'll have to use alt here, so I'm gonna have to bring out choosing a combinator because alt is a sequence, is it not? No, it's a choice. This is just in combinators branch. See at the top. Um, use I don't want to have to say nom colon colon every time. So um, branch. So I know I'll have to use alt here. And alts will either be try an int32 first, so I believe digit 1, or this list. So let's make a list parser, which will be delimited. Then where is delimited? It's right there. It's a sequence, okay. So sequence delimited. I wish I had Rust Analyzer bring up the docs for this, but it just doesn't. It just doesn't. I wonder why that's the case. This Analyzer uh doesn't bring up docs for external crates. Oh, here's the Stack Overflow page with my situation, LSP0 and Rust Analyzer. Um, yep, no idea why. Zero idea why. Okay, whatever. Who needs docs? Okay, delimited. So here we'll have yeah, character. There'll be this character. This should be in a tuple, right? No, of course not. Something, and then character this. But of course, this something should be what? A separated list. Um, separated list. So separated list, and it can be empty. So here, where is separate list from? Multi separated list, and here does it have to take in a tag? Let's just use what's provided to us. Tag, and then digits 1. Yeah, that's our list parser, and then probably want to use alt this, and then list parser. what am I doing here? I want to do values, right? Values. Value. Returns the provided value if the child parser succeeds. Um, okay. How did Fast and Live do this? Um, value. Alts. So you can just do that. Okay. Value. Where's this from? Combinator? I don't want to have to like type that out all the time. Um, value data ints. Data ints. What? How can I use this? Um, value output one. So okay, I need to use a map here, basically. I have to use a map. Uh, this is not fun. What does alt return? Okay, could you use alt like this? Um, I don't want to have to type, whatever. Okay. Combinator map digit one. Wait, is this how you use map? Map. Wait, there's a lot of maps here. Let's just look at the basic map. Yeah, digit one, and then S. Data ints I data ints S dot parse from an I32, and then just unwrap this because I know it's going to be some kind of digit. Okay, and let's bring this into a new line. I. Okay, and then here we would map from our list parser. We take S, and then this is the hard part. This is the hard part. So what does the list parser output? It outputs a separate list which could be optional, I believe. Separated list. A vector. It could be an empty vector. Okay. So here, like this. Let's do this. Okay, sure, this works. So digit one returns a string. S here is actually a vector. It's vector of strings. So, but keep in mind it could also contain more lists inside of it. which is tough. How do you handle that case? Handling recursive, okay. Parsing recursive lists. Nom, I don't know how to do this. Non-recursive. Okay, there's just a whole crate for this because it's so complex. Um, take until you run to the closing tag. Oh, that's the issue. What is this? JSON? Okay, this is pretty similar to what I have. Um, okay, array. How do they handle array? They call array here. Okay. JSON inputs. So JSON, where is the JSON function? Arm. Um, JSON. Ah, there it is. WS JSON value dot parse inputs. WS? WS. What is WS? What? Is this some function in nom? WS? What is WS? Is it in here? WS. What does WS do? This is the first mention of it here. What? Okay, I'm just gonna ignore it. I don't know what that means. Um, Parse inputs. Okay. Oh, here. It's right here. Oh my God. Um, okay. Takes in. Okay. Sure. Delimited. Multi-space. F multi-space. So this just removes the white space in the beginning and end of of the string. Which there is one here, I believe. There's a new line here. And there's also some spaces here because I don't believe Rust removes the beginning white space, the right white space from the object. So yeah, and it's called WS for white space, of course. Duh. Okay. Dot parse input. Okay, WS dot parse. What does this return? um, a JSON value. Okay. Where import JSON value? JSON value? JSON value. Says to use JSON value. Oh, here. Okay. So fn parse does not exist. Really? Dude, I wish there was an outline. Function outline. Array objects, JSON, that parse. WS does return. Okay, what does it return? A parser? A parser. Um, okay. I guess what I'm interested in is the array. Because an array could include an array. No? Okay, array. Where's the array? String, WS, array. Okay. Character, white space, separated list, white space, character, JSON value. Um, JSON value. Okay, JSON value is over here. Okay, use JSON value, alt, dot parse. Dot parse? I've never seen this dot parse syntax. Like, usually when what I'm familiar with is this syntax where you return a parser with whatever with the parser, and then you parse it by calling it as a function. But I guess it's just the same thing. Okay, we can just map here. Alt map, and then you can call array again. Array. Vec. Where did you get these functions? JSON value array. Map array to. Okay. Where'd you get this from? Class JSON value. I'm okay. I'm confused. How do they get? Where did they get this from? Where did they get this from? JSON value, which is this. JSON value. Dude, I am so okay. Separated list. Separated list. Also, where do they get these from? Num? Wow, I'm confused. JSON. JSON, 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 JSON. Okay, here, and then we call JSON value, okay, which is this, and then we take it and we try these. So we try null first. Um, 216. These are just tests. Yeah, okay. Value, okay, return null if the tag is null, okay. Otherwise, map Boolean. Okay, so where is the Boolean parser? Where is the Boolean parser? Where is the Boolean parser? Mate, where is the Boolean parser? Where did you get this? Where'd you get this from? It has to be in this file because we just use nom here and hash map. So it's literally in this file. Character, string, array, objects. Where did you get this from? Where did they get this from? Hello? Maybe it's in examples? Oh, it is in examples. Okay. I want to know how you do arrays. Okay. Context, array, preceded, car, cuts. What the hell is cut? Terminated, separate list, preceded by space, uh, then a comma, JSON value, preceded by a space, and then a terminating. Oh, that's an interesting way to do this. Okay, what does cut do? Combinator cuts. Was I using this? No. Is it in here? Cut. Transform a recoverable error into an unrecoverable failure. Okay, what is context? Error context. Create a new error from an input position, static string, and existing error. Context combinator. Oh, was I looking at the context in this file? What? This context should be error context, no? Oh, I guess here you provide context to the error. Which I guess is nice because in Nom it can be really hard to figure out why a parse went wrong. But they don't give an example here, which is annoying. Parsing in context in Rust with Nom. Okay, context. Context combinator. Okay. This means you can use implicitly. Okay. Context. Context to wrap our actual parser and add the scheme context to it. Will be marked with scheme as a result. Okay, so it's not really mandatory. So the real parser is this. Everything up to here. Yes. Cut. Terminated. Terminated what? Separated list by a space and this. So maybe we shouldn't use the limited. We should just take note of what they do here. Um, okay, let's look at the tests first. JSON value. Here they use JSON value. Okay, maybe I should. Oh, okay. GitHub is its own shortcuts, so I can't use Vimium. Very nice. JSON value. JSON.rs. Yes. Take me there. Okay. So here, JSON value alternates between all this, and what I'm interested in is the array. And what does the array do? FN array. Okay, so it parses using JSON value. Okay, JSON value. Okay, it just alternates again. Okay, so maybe I need two data parse functions. One is a data value, which takes in an input, which is a string, and it outputs an iResult, of course, of a string, which is the input again, and then self. Yes. And what this does is it alternates between, I'm just copy pasting their method, a map of, okay, so now we need a int int value. They just call it I am so confused. So this should be a this is a parser and this should be a closure. How did you make this a closure? Wait. This is an enum, isn't it? It is, just like mine. So you can just pass in the type, so a specific kind in the enum. So for example, JSON value array, and that's implicitly a closure that accepts one input, which is whatever the hell this is, and it outputs an enum value of that kind with that whatever the hell you put in there. Okay, okay, okay. I'm starting to get it. So really, so really, um, so really, oh, where was I? JSON value, JSON value. I don't understand how they're... Okay, this calls a function. Okay. Okay, let's just call this data parser. Okay. Um, well, I already have that, don't I? Here. Okay, let's call this data parser. Okay, so that's this. So really, this should be separated into its own list parser that has the same signatures. Where the hell was that? Okay, it's one, register one. Okay, like this. Um, and then this should be, I mean, it's an int parser, which is so basic. Okay. This is like this. Okay, one more piece of the puzzle is if an array, what does it output? An I results. But it also does this. Oh, okay, so it basically like JSON array can call JSON value, or array, fn array can call function JSON value, which can also call function array again, which can call JSON value again. So that's how that works. So really, this should be a separated list, and we should take the data parser into it. And we should consume the input here. Okay, it's giving me an error. Oh, tag. Haha, just make this tag. And then here, we don't need to use this closure anymore. We can just say data, data, list. Boom. Um, okay, why is it doing this? Because these are all just separate functions. Okay. Self. Sorry, self. Type mismatch. It's function, it takes in vec data. Okay, JSON value turns the JSON value. Array returns a vector of JSON values. Okay, so this really needs to return the same type here. Okay, great. And this is, what is this? just didn't get the namespace right. Digit 1. This is from character completes. Okay, cool. Character completes digit 1. And then, okay. Okay, tag. Tag is bytes complete. Sure. Tag. Okay, data parser self. Still get an error because I didn't replace this. Oh my god, it works. Let's try it. Yeah, let's test this. So config test mod tests. Okay, function. First of all, denote this with test. Parse data. This doesn't return anything. Also, let's use crates, whatever. And then here, how do we test the parser? Okay. Assert equal. Okay, I'm not really confident enough to write a test. I just want to um try parsing the input. Let's just try debugging by parsing the input. So let v equal inputs dot lines dot parse, sorry, lines that map. For each line, we'll try outline that try data parser line. Right? Sure, let's try this. And then this is gonna be a mess. But let's collect that. We're gonna get a whole bunch of OKs and then like the entire example text repeated over and over again. But I just want to see how this looks like. Debug V. And then let's use a reference. Okay, let's see how this goes. It's probably not gonna go well, but we'll figure it out. Promising? Promising? Okay, what does the fuck? Okay, what does the input look like? Okay. Okay, we're getting somewhere. It consumed everything in this line. Great. And now we have a list of ints 1 1 3 1 1. Okay, here 1 1 5 1 1. Great. Okay, we got an error here. Code tag. Yeah, I wish I used context now. I wish I used context. I mean, that has to be in the list parser, right? I'm assuming the limited just took in this this opening bracket and this closing bracket. Is it greedy or not? I want to know. Um, Here, limited. Yeah, no idea. Third line worked. Oh my God, the third line worked, and it has a list of a list. It Wow, it worked. It just worked. We have a nested list in here, and then a list with 2, 3, and 4. Perfect. And then, oh, this error is because of the empty line. It's because of the empty line here, which is really easy um to parse. It's really easy to to parse as a pair of packets, I guess. So I guess it makes sense to call this a packet pair then. And it's not a vector data, but it's a tuple, two data two data units. Um, yeah, wow, it's crazy how that just happened. It's a tuple of two data units. No, no, this isn't right. It's a vector of data. The vector data, don't call it a packet pair. Call it a packet, and then so I saw that the data parser was working perfectly. It was working perfectly. It only failed on the empty new lines, which is good. So now what we need to do is parse each packets. And this is easy because we can just do this. Here actually we don't need to call this data parser. We can just call it dot parse, self parse. But I like how in the nom crate, in their example of the JSON parser, they just called it JSON value. Like, isn't that so nice? But that was a function. This is also a function. They just called it JSON value. So you knew that it was a separate list, separated by commas and a JSON value. Like, what is a parse, you know? So maybe I should just call this value. Should I call it value? Fuck it. I like how they did that. And this needs to be, okay, here. Um, yeah, sequence delimited tag. Um, and then here we just take in data value. Okay, that's really nice. That's really nice. And then we say dot, can we map this? Can we map this? No, no, no. That wouldn't work. We map like this. We map with combinator map. And we take in this yeah, we're taking this and what we do is we just say packet. Okay, then we no longer taking the input there, but we take it in here. Perfect. Okay, let's use cargo format just to make sure everything looks nice. Okay, cool. Um, and this should just work, hopefully. And also package, just call it self. Just call it self made. Yeah, self. So um, now we can create a pair. Struct pair. It's kind of dumb that a packet is really just a fancy name for data, and I have to create a whole new struct to store a pair of packets. But I mean, this is a technically more accurate, technically more accurate abstraction detail. And then we can just call this value. I don't like value again. I just okay, just call it parse. Let's call it parse. And let's call this parse as well. And in pair, now we can do this. Function parse. So same thing here. And now what we do is um okay. I want to find something like preceded, but here. Array, where's array? Something like preceded, terminated. Okay, terminated. Terminated, I believe, gets rid of XYZ. Wait, terminated AB, XY. So return AB. Yeah, return the first one, get rid of the last one. Okay. So terminated is what? Sequence. Okay, sequence terminated. And we take our packet and we it's terminated by a new line. So here, line ending, which is a character completes. Character completes digit 1, line ending. Line ending. And then we do this again. And how do you do multi pair tuple? Yes, that's what I want, a tuple. Except I want to, yeah, tuple. Okay, sequence tuple. Sequence tuple. And inside a tuple, we put this in there. And now we want to wrap this tuple in a terminated. So the tuple is terminated by a line ending. Yes, and then now we take in our, pass in our input. And we pass in our inputs. Oh, and we map this. Okay. We don't pass in our input, we map this. Combinator map. Map this to self. Oh God, what's happening? Single two tuple as an argument, but it takes in two distinct arguments. Does tuple return two distinct arguments? No, it returns a tuple with the inputs and the tuple. Okay, I'm confused now. And terminated just returns confused. What am I doing wrong? Okay, I want to format this because it's confusing to understand right now. I. Okay. What the hell is our input here? To do. What is it? What are you? You don't know. You don't know. You don't know what you are. I don't know what you are. Okay. No information available on tuple. Great. Okay, terminated. Terminated by a line ending. I thought I could just pass in self here, to be honest. Oh my God. This isn't. It's not a tuple of two packets. It's just two packets. There you go. Okay, great, perfect. So now we can just all consuming, right? All consuming. Actually, how do we pass in the inputs multiple times? I read this article by Adam Chalmers, and this excellent article, very straightforwardly and clearly demonstrates how to use nom. Oh, just like this. Um, no, that's not good. This is not good. That's not what I need. I think what I need is I need to apply multi. Applies the parser 0 more times and returns the results in the vec. Okay. Let's do many then. Okay. Let v equal multi many? Multi many. I mean, I hope it should be one. Many one. Pair parse. and just pass in our input and return V. Okay, let's see how this goes. Looks like it worked well, except for we didn't parse this last line. Literally just the last two lines we didn't parse. Now why is that? Because we assumed that after every pair of packet, there should be another new line. So we have the line ending for the first packet, and we have a line ending for the second packet, but we also have a line ending after that pair, which doesn't have to be the case. So it's guaranteed. Looks like it's guaranteed that. Actually, we should just probably check the input, the actual input. I bookmarked that for some reason. Okay, so where do I want to go? Projects. Okay. Let's go here. Projects. Here. 13 source, and then XT. Okay. Okay, let's take a look at it. So let's open up nerd tree. Let's look at this. Is there a new line there? Let's test it out. I mean, what I probably should do is just put like a space 0 or something, right? Where is it? Multi-space 0. That's what I should do. Put a multi-space 0 at the end. Fuck, why did I do that? Okay. Close that. Let's run this. Yep. Lots of output because I didn't. Oh, too much output actually. I just want to see the inputs, to be honest. Can we just do that? No? How? Okay. Maybe unwrap? Okay. Unwrap dot one dot zero. Okay. Okay, so what did we not parse here? I'm assuming just the last line, which begins with 0. Okay, perfect. Okay. And there is a new line at the end of it. Okay. So it indicates to me that it's not necessarily terminated by the line ending. Okay, so what now? I think instead of using terminated, we use preceded. Fuck, okay. Uh, shit. Okay. I don't like you. Preceded? Yes. Okay. Preceded. And then instead of terminating from aligning, we are preceded by multi-space 0. Yep, multi-space 0. Which is what? What's your namespace? Character completes. Okay. Multi-space 0. Okay, once we do this, when we run this again, yep, should be nothing. Perfect. Perfect. Okay. So I don't need to do any testing because I literally just did it. Example. Yep. Okay, nothing. And then we unwrap that and get the outputs. I can just quickly verify with our example here. Okay. So we have our first pair, which is a packets containing 11311, 11, another packet containing 11511. Perfect. And then we have our next pair, which is a packet which contains a list of 1, then a list of 2, 3, and 4. Okay, perfect. Then another packet containing a list of 1 and an into 4. Perfect. And then 9876. Yep, yep, yep. 44, 44, then 44, 444, then 7, 777, then 777. Okay, perfect. A packet containing an empty list, which is perfect. Yeah, that was perfect. Wow. And a packet containing integer 3. Yep. Then another pair, which is an empty list nested multiple times. So list containing nothing. So nothing, a list of nothing contained within a list of nothing, a list of that. Wait, a list of nothing contained within a list contained within another list. Yeah. Yeah. How many lists do we have here? Okay, the packet contains one piece of data inside of it. Okay, and that piece of data is a list. Okay, so this is the one element of this vector of data, which is a list, which contains a vector of data again, which is also a list, which contains a vector of data, which is nothing. Okay, this is perfect. Yep. And then 1, 2, 3, 4, 5, 6, and 7 at the top, and then we descend all the way down, and then 8 and 9. 1, 2, 3, 4, 5, 6, 0, 8, and 9, and then that's perfect. Okay, great. Um, and then I guess it doesn't hurt to also make it look nice, right? So we'll just implement, um, I like implementing, so there's two ways we could try to turn that ugly display into a nice looking one. We could use, there's actually three ways. We could implement toString, we could implement standard formats display or standard format debug. I'm impartial to using debug since I am the only user of this application. So let's do that. No user is going to be looking at this. So we implement this for data because once we implement it for data, then we can implement it for packet really easily, and then we can implement it for the pair really easily. Okay, so doesn't this have a type to it? No? Okay, it just has a format. Okay. What do we do here? Um, oh, this is gonna be some shenanigans, isn't it? Okay, yeah, there's gonna be some shenanigans here due to the list. Yeah, we don't need to derive debug anymore. Um, okay. And then here we want to display list, format list. Let's just say taken self and taken the self, right? How does this work? Okay, well, I know what we're returning. We're returning a string. Okay, and then Oh, shoot, this is recursive. See, the only reason why I was able to implement um parse and list parser was because I looked at an example of JSON. So how would we go the other way? How would we go the other way? Oh, wait, traits? Traits can only have the functions that are explicitly listed inside them. How would I do this? I won't. It's too hard. It's already too hard. I maybe I can hijack vectors native um native display. Yeah, yeah, that's what I'll do. That's what I'll do. Yeah, of course. Yeah. Okay. Um, let's write to F and we'll write in self um hmm, we would have to do pattern matching, wouldn't we? Okay. Match self. Um, data int of some value. Value I. Okay, we simply return I. All right. Data list v. Simply return v. And that's all there is to it. Nope. Incompatible types. Oh God. Oh no. Oh no. Ah, simple. I dot toString. ToString. Simple. V dot toString. Uh, format v. Aha. No error. Yeah, this is a macro. Error again. Doesn't. Okay, so let's do this. Aha. Wait, v can contain data, so it probably wouldn't look right. Um, no, it would be okay because this would get called again. And okay, first of all, cargo format, please, please. Right now, I wanted to edit. Okay. And if it's a list, then it calls again. And gets called all the way down until we get an int, and then we return, go up the stack trace. Um, and yeah, this will be okay. Yep. Yep. Okay, this will help a lot in making it look nice. So if I cargo run now, yeah, it looks a lot better. Oh, yep, a lot better. And now we could also probably do this for packet. Implement standard format debug for packet. And this is a lot easier because now we just write into F um, formats Or we could just say self.0, and that would be it. Vec data is implement stuff. Okay, like that. Perfect. Um, yeah. And now if you run this, yeah, this is pretty much is just it. I mean, this is literally what we have here. Um, we have in the example. I mean, if I really wanted to, I could further reduce this. I won't write all this again. For pair. And what I could do is um, do this, new line, this. This isn't portable for Windows, but screw Windows. And then we could do self.0 dot 0 self.0.1. Oh, right, and then it's debug. So do this. And then if we run this, I mean, what more can you say? There's this weird comment here because it's a vector of pairs. Um, so we don't have to include this. Okay, but now it's kind of unreadable. Yeah. Okay, this looks a lot better. And this is good. Okay. I think we could just unwrap this and call V. Yeah. Okay. And now we don't care about the remaining input, just care about V. And that's good. Okay. Okay, now I could end here or I could continue. Um, I mean, the way that I've abstracted this kind of makes it easy since we don't have to look at data anymore. Um, Technically, we don't have to even look at packet. All we have to do is look at the pair. So we've parsed it, now we can compare. Or determine order. Um, yeah, determine order. Okay. We pass in a borrowing of the self, and then we're returning a boolean. Okay. All right. So for this, what do we do? I think let's have an index I. we start it at 0, and then let's I guess we could do self dot zero dot that's a pair. Wait, self dot zero is it's a tuple containing a pair of packets. So take the first one, and it's a vector of data, and now we want to iterate through it. That's kind of silly, but whatever. We iterate through it, and we're gonna map? No, mapping's not right. Mapping's not right because um it's not one-to-one. We're not mapping each element to a Boolean here. So for example, we're not mapping 1 to a Boolean. So it wouldn't be right to use map. Okay, let's try again. I think we just use a for loop here. And for item in self dot zero dot zero dot zero. So the item is some piece of data. Okay. Okay, this isn't a consuming iterator, so we don't want to do this. Okay, just to do this shit. Yeah, that's what we want. Okay, maybe what we want to do is do something like this. Dot iter dot enumerates. So this way we don't need this anymore. We can just for index item in there. So index is usize, and then it would be so much easier if we could just pop stuff from the vectors. But that would require a clone, and I don't want to clone. So what do we do instead? I was thinking of I was thinking of getting each elements, or I was thinking of first checking the length of each packet compared to one another. And I was like, okay, so if the left packet was smaller than the right packet in terms of how many items are in it, then we can just immediately know if the left one is smaller, then the inputs are in the right order. But if we look at pair 3 in the example, the left packet only has one element, and the right one only has one element as well. Okay, so then we go into the next step. So I thought for some reason I thought that the right element had 3 elements, that the right packet had 3 elements in it, and the left packet only had one. But that's not the case. So maybe we can do a first check using number of elements. So first of all, let's have the left. Let's use aliasing just to make our lives easier. So the left packet is this one, and Actually we could just do this. Let left, right equals self dot 0, right? And then cannot move out of self. So these should be packets, okay. Can we just make it a reference, please? See, I thought self was already a reference, but okay. Self is a reference, but when you access it, you don't get a reference? Okay. I mean, let's just do that then. So we're getting references to packets. We're borrowing the packets. We're doing immutable borrows, so we're only going to be able to read from it, and that's okay. I don't care about writing to them. We're only reading right now. Um, okay. So what now? Um, hmm. Okay, so say if let's match lefts dot zero dot len, and then we're gonna compare this to rights dot zero dot len. Maybe I should write some functions to not have to write all these zeros in. Okay, but anyways, if we get um hmm, okay, if we get less, then we know that we want to return true. If we get anything else, now if we get equal, then we don't know what to do. But if we get greater than, then we know it's false. And then if we get equal, well, um, then we do stuff. That's when we do stuff. So what do we do? I don't like how I've written this because it forces me to use a level of indentation. So I'm not going to write it like this. I'm going to say, I'm going to replace it with an if statement. And let's just not use compare. Although I do like compare, that's why I use it right now. If it's not equal to this, then return left.0.len is greater than, it's less than, write that 0.len. Otherwise, now we do our stuff. So here, check if left is smaller than right. And then otherwise, continue. Actually, everything here seems to be very recursive. Like what I mean by that is you can consider a packet to just be a data, a instance of data, and what you can do then is um, check the length of the data, compare it from left to right, and if they're equal, then now you would uh, get the compare each from each elements of data inside of that piece of data. If that makes any sense. Okay. Well, yeah, otherwise continue. So now we want to I guess do this. So we know that they have the same amount of elements inside of them, so we can um assume that the index applies for both of them. Dot zero dot length. Now we can just compare. I wonder if there's a way to take two lists, two vectors, and then create a new vector whose contents are um tuples of these of the two vectors that it came from. Kind of like Python zip. Python zip. So here we have two iterables, two lists in this case. Each of them have three elements, and then when you call zip, result equals zip, then we return a list whose elements who has that has the same amount of elements, but the elements are now tuples. Um, for each tuple, the zeroth element is the first element is the nth element of the first list, and the first element of the tuple is the nth element of the second list. So it's a lot easier to look at than it is to explain, but yeah. I wonder if that has anything, if Rust has anything like that. An iterator that takes two other iterators simultaneously. Okay, it does have it. Um, Examples, por favor? Rust zip. Okay. This, okay. Um, okay, yeah, it does. It does. Okay, so rather than using a for loop then, let's try to use functional syntax. So we're going to say left.0.iter.zip. Zip. And what is zip? Okay, what does it do? Um, okay. So zip right dot zero dot iter. Okay. And this is bad. This is bad. Okay, we have to use a for loop. Okay. Um, left maybe just L and R in. So L and R are left values, left value and right value. Yeah, there should be data. Okay. And now we want to match these. Okay, so match LV RV. So now if it's some data ints compared to some data ints, so data int with value, I don't know, um, RI and LI. LI, okay. Then we want to we want to return Li is less than Ri. Otherwise, if we have some if we have some data int li and some data list rl, right list, left integer, right list, and then we also want to check for list of left list and right integer. Then this is bogus. This is bogus. Yeah, this is bogus. We should separate these two, unless if I want to make a function that converts from a turns a integer into a list, which God, I should probably do that. Um, to list from self and return self. Um, so match self, okay. Self it into value. Then what we want to do is return self list of a vec of v, and that's it. Otherwise, I mean, if you're already a list, I should probably be explicit about this. If you're already a list with some vector in it, then self.clone. You don't implement clone. Okay, well, I don't want to implement clone. I'll just v.clone. Clone the vector. Yeah. Oh no. Expected data found I32. Oh. Um. Oh. Okay. So, yeah. Vector of self int v. Can I move out of there? V.clone. Yeah, just expected vec data. What are you? Can I just copy? clone. Maybe I have to dereference you first. This is so nasty. Can I say this? No? Okay. Method clone exists for... Okay, well... Okay, I have to implement clone. And I think I can just do this now. Yep. Okay. So now I don't have to um, separate these two. I could just say li.toList. What? Oh, okay. This has to take in a... You know what? This makes sense. Fine. Then I don't need any of this except for you. Okay, well then it doesn't make sense to... It doesn't make sense uh, to put these together. To list... Oh god. To list... li. Maybe we'd have to have some function called compare list. Or maybe we can do this recursively by constructing a pair whose that contains this and um, let's just call this R. Yeah, this and RV dot clone. It's yeah. I have to turn these into packets. Shit. This what does packet take in? Echo data. Oh god, it's getting messy quick. Packets. Then another packets. Dot determine order. Okay, great. And then this is literally the same thing as this, but um, we do right left value dot clone, and then here is data to list. right integer. And then the last arm, what? Okay, do I have to make these references? Arguments to the structure. Oh, um, do that. And to make this a tuple. Okay. Arguments to this function are incorrect. Packets, vector. Wait, this one? Data.toList. RI is a vec of what? Int list. Int. Okay, non-exhaustive patterns, list and list. Okay, so that's the last case. Um, okay, so on this case, where we have a list and a list, what do we do? Um, we just we do the same thing. Um, left value dot clone, then pair packets, right value dot clone. Yeah. Cannot move out of a shared reference. Okay, I'll just implement copy then. Just implement copy. Oh my god, it works. Okay, what now? Any errors here? No? Format this. CR. Okay. Cannot be implemented for this type. This field does not implement copy. Great. Great. Okay, which means we'll have issues here. Loop. Wait. Zero elements. What if it has zero? What if they have zero elements? Then return true. Okay, cannot move out of shared reference. I mean, if it doesn't like this, then could I just do data list rl dot clone? And do the same thing here, maybe? not that. LVLLL clone. I don't know what I'm doing. What am I doing? Data. Oh, this is messy. I hate that the fact that we have to use vex here. I wish I could use tuples. But I can't because it's a variable length, so Lord. Data list rl.clone. Consider using the pattern binding ref. What does that mean? What is ref? I don't know what ref does. Ref. Okay. Um, ref. 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 Oh, what? Okay. Rust analyzer, you're drunk. That works? That just worked? Okay. This is the nastiest code I've ever written in my life. This is the most disgusting code I've ever had the the displeasure of looking at. Okay, whatever. Let's let's just let's just do this. Okay, so we're taking V, we're iterating through it. We are mapping each pair, right? How do you not know what V is? Hello? GR? Okay, do you know what V is? You don't know what V is. V should be a pair, right? Yeah, vector pairs. Vector of pair. Oh, oops. V, this is a string and a vector of pair, right? Yeah, okay. Now, map each pair, pair, pair. No, we need to enumerate first, and then map each index and pair. Um, um, so that we return the index and the pair, and we determine the order of the pair. Okay. Now, and then we want index plus 1, because it says here that the first pair has an index of 1. Okay. Uh, in the above example, the pairs in the right order are 1, 2, 4, and 6. So now we want to filter by I and B for bool, right? I is usize, B is bool, and we want to see if just filter B. And then we want to map this again so that if we take I and B, we just want to turn I and then we want to turn the sum. And then we will have the first first problem be this. Okay, it's complaining. Dereference B. In fact, just do this. Another error. Expect type use size. What? Oh, I keep forgetting that if you want to do like something like that, you have to do this. You have to actually no, what we can just say it's a reference, right? Yeah, okay, cool. Another error. Type annotation is needed. You don't know what you are. Your use size. Okay. Debug P1. Unused variable I. Okay, we don't care what you are then. Okay, let's see if this works before I format it. Okay, we have a Stack Overflow. Oh, great. I don't know what's going on here. So I will not run this for now. And let's instead try to determine the order of the pair 1 in the example. So v dot v0. That's determine order. Yes, perfect. All right, let's see how this goes. False. That wasn't right at all. That wasn't right at all. So what the hell happened? I kind of want to debug this. So I'm going to use VS Code for this. And I don't have VS Code up on OBS yet. And I tried using this GDB web interface. What is it called? GDB GUI. I tried to use GDB GUI, but it just wasn't working, and I didn't want to figure out how to make it work. So I'll bring up VS Code right now, and then I guess I'll just add it to OBS. Right. Um, Control KF to close this folder. Okay. And then I believe it's Control K, Control O to open another folder. Yep. Control K, Control O. Then I'll open up day 13. I'll go into main.rs. And then see what goes on over here in determine order. I'll press F5 to debug. And then I have to set up the launch configuration. I believe it's targets, debug, and then D13. Okay. Okay. Um, okay. Guess I'll add VS Code here. All right. So I have VS Code here. All right. So okay, check if left is smaller than right. So they're the same length. They're both 5 elements. So um, okay. So now we're checking LV and RV. So so this should be, yeah, left and right dot 0. So it should be this guy, which is 1, and this guy, which is also 1. So let's test that. LV and RV, where are you? Yeah, okay. And what are these? They're ints. What? Why is there a list in here? Oh, these aren't, they don't have values in them. Only these two ints have values in them. So so they're ints. So should go here. Oh no. Okay, so this is the issue. They're the left value is 1, but the right value is 1. So 1 is not less than 1, so that's why I returned false. Okay, so I need to add another statement that says um if li equals ri, then continue. Otherwise, return li is less than, if li is less than ri. Okay, that's what I was doing wrong. Then clear editor history. So that's, if I reload this, then um, the cache won't be right, no, wrong. Okay, so that returned true, which is, yes, that's what it was. Inputs in the right order there. So now, um, let's try this out with pair 2. I should really, okay, pair 2 minus 1. Okay, there you go. So that's how we know it's pair 2. Overflowed its stack. Okay. Now what the hell is going on over there? Okay, let's go to editor history again. And now let's run. Okay. Um, okay, so left 2 elements, right is 2 elements. So we should continue. And let's see what LV and RV are. The left value should be what? Oh, I just don't get to see this. I don't get to see this. I don't get to know. Wait, this is pair 2, is it not? 2 minus 1. The first pair. This one. Which is this one. Okay, these are just wrong. Because it should be this a list of 1 and a list of 1. So we should go down here. In which we do. Okay. And then now I just return a pair of packets and I clone this. And then I try to determine the order of this pair. Okay. So they both have the same elements, which is just okay, I don't get to know what that is. LV and RV? Yeah, they're ints of 1. Both of them. Okay. So this returned true, I'm assuming. No, it's continued. Um, erm. So did this return true? Wait, what? They're lists. Oh, so it's just gonna keep on creating pairs of packets then. Hmm, that's a problem. So I would need to check if wait, no, they should contain what is going on, man? Oh, okay, I know what I'm doing wrong. I'm taking this list and this list and I'm putting it inside of a packets. When really what I should do is I should unwrap them, quote unquote unwrap them, and then take their elements and put them into a packets. I think okay, so I have some idea of what I'm doing wrong. Um okay, so what do I do now? What is LL? It's a vec of data. So I think what I could do is I could just call ll.clone from here, since packet already takes in a if I go to its declaration. Yeah, vector of data, so I don't need to call vec again. And in fact, wherever I did the same similar kind of stuff with um calling a packet of vec of data of list of a list, I could just replace that with um x x.clone. And in fact, this data.toList returns a list of lists. Um, when in fact, I think this is wrong too. This has to be wrong. Yeah, I could just call vec of data int of ri. Oh, okay. So I don't need to, you don't need to exist. Okay. So this simplifies things a lot. Data int. And then this could just be rl.clone. Okay, that's a lot nicer. And then let's try now. So left side is smaller, so they're in the right order. Okay, perfect. Now let's look at the third pair. True. It's false. That's not in the right order. Um, okay, so what went wrong there? Okay, what went wrong here? So let's clear the editor history and let's debug. Um, right, okay. So step over is F10, which is a whack-ass key. Not gonna lie. Okay, we're comparing 9, yes, with, doesn't go that far. Okay. So this is an integer with a list. Yep, integer with a list. So we return a pair. Um, and then we make, um, we convert this from a, hmm, yeah, we convert this to a packets, and then we determine the order of this. So if we determine the order, wait, what does this return? True? Eh. Okay, you're gonna need to run that by me again. I need to step in at that point. Yep, yep, yep. Okay, step in. Step into? Step into now or step into after? Now? Okay, now. Okay. So this, okay, yes, we have a packets with just 9 in it, and then a packet with 8, 7, and 6, which is, okay, good. So, oh no. Convert and retry comparison. And then we take the first element. Oh no, this is what I was worried about. Okay, right side is smaller, so inputs are not in the right order. Um, okay. So, how do I deal with this? I think I could simplify the workflow a little bit. I don't need to determine if they're smaller than the right. What's the smaller than right? Oh, but this makes things nasty then. Stuff gets nasty. Okay, I need to reread this again. Hmm. I think it would be a lot easier if I created a function called compare lists. Compare lists, right? Or maybe compare, and then we'll say compares between two lists. Um, Actually, we don't even need to compare between two lists, don't we? We could just compare between two of the same types. Compares between two of the same type. Um, in other words, i.e., i.e. between two lists, two um, data list, or two data int. Okay, and then we have our self, and then we have the other, which is also a data. And this returns a bool, of course. And then we match um, self and the other. And let's make this a reference. Okay, so a lot of the code that we had down there will um, instead be relocated up here then. Where the hell? Okay, impl pair. Yep, okay. So a lot of this code will be relocated up there. Um, and I guess it'll be an option bool, wouldn't it? Since if the, yeah, option bool, because what if you had two ints that were the same value? Then we'd have to return none. Okay, so let's just copy this wholesale, I guess. No, we just need to copy this. Okay, and then actually, yeah, let's just copy everything wholesale. Okay, now um okay, if this, then turn none. Otherwise return this. I'll return some of this. Okay, and in the other case, if we get either this or this, we just the fuck. Okay. Return none? Question mark? Maybe I should return a result that returns an option to a bool. Nah, this is okay. And then if we get this, then now we look at the left list. And the right, okay, so for D, for data in left list. Oops. Can you zip? Can you zip between two lists that aren't? See their documentation for more. Okay. Here we are. Can you zip between two lists that aren't the same size? That's what I'm wondering. Can I run this? Oh, I can play with it. Okay. Okay. I don't care about this anymore. I just want to debug this. Editor. Okay. Can I run with control enter? Can, of course I can. Let's just do this dot collect with a intuitive vec. Let's try this. Oh, okay. That's perfect. Okay, so it just zips the zip length is the least or the minimum length between the two vectors. And it only attempts to zip between the shared items, I guess you could say. So that makes this perfect. Then so I can say for left value, right value in ll.zip, that iter. Wait, it's a list. That's 0. Oh. ll.iter dot zip rl dot iter. So this is now data. Self lv dot compare rv. And then we can just return that. No? Expected unit type. Okay, fine, return none. Li is not bound in all patterns. How about I just replace you with this? Which match types. Expected option pool found. return. Well, compare already returns a option, doesn't it? Oh, 0 elements. Um, True. Sum true. And then down here, down here, I could just compare between the two packets, the two data values. Oh, yeah, this makes everything so much easier. Turn LV dots compare to RV. Boom. Um, okay, I just match LV dot compare to RV, right? No, no, this is terrible. Oh my God. So, okay. Here, if they're different data types, then I need to return well, LV dots to list. Oh, I wish I had to list now. This is awful. This is awful to do. Okay. Here, I should just handle it here. I should just handle this logic here. Okay. Okay. Here in this case, okay. We have an int with value li and list with value of ref rl. Then to do. Fuck this. If you have a list, value rl, or ref rl, and ints the value ri, yrl, ll, then to do again. I just thought about what if I just made a to list function in here that takes in the self, and if the self is an integer, returns a list, right? But if it's the self is already a list, then it just returns the self again. But I don't know. This is I'm already here. Okay. Um, Return data list vec data int li dot compare to the other. And then here we do the same thing, but instead of this, we take the self and we compare it to the other. What is this? Reference. This is whack. Do I not need this? There we go. Okay, so now here we just do LV return LV dots compared to RV. Oh, we have to match this. Okay. Match. On none, continue. Otherwise, on some B, return V. Return V. Wow. Okay, let's see if this works. Okay, the first pair. First pair. Okay, so left side is smaller, so inputs are in the right order. Okay. True. Great. In fact, let's just try this. Shit. 28. Definitely not right. Okay, so second pair. Maybe I should just iterate through V. Press 9. Iterate through V, and then map each pair such that we determine the order of the pair. And then we collect this into a vector. Okay, first one, second one were true. Third one is false, which is right. Fourth one is true. Fifth one is false. Sixth one is true. Seventh one we return true, but it's actually false, and so is the eighth. Okay. Now what the hell happened here? Okay, so let's examine the seventh and eighth then. DTD. 7. Turn order. Okay. Time to go to VS Code. Going to clear editor history, and then yeah. Okay. Yeah, debug this. Okay, so the seventh one. This is the seventh pair. Why does it have 5 elements in it? This isn't right. Clear editor history, please. Try again. Okay, there you go. That works. Okay. Maybe I should just return false, because these lists contain. I should return false here, because these lists contain no elements in it. I don't know. Okay. Okay, so we're comparing this. So LV is 4. What is it? What? Can I debug this? LV. PLV. P LV. Okay, PRV. This is an empty list, apparently, but didn't. Okay, the outputs, or terminal rather. I mean, it shows it correct here. Um, okay, step in. It's a list in a list. Okay. Oh, okay, I see what happened. Okay, so we're gonna go into this for loop, but okay, so when you zip LL and RL, you get um an iterator with 0 elements in it. So this will just skip that and just return true. So I need to handle the case when the left list has an non-zero amount of elements and the right list has 0. And I need to handle the case where the left list has 0 elements and the right list has non-zero amount of elements in it. Okay. Okay, so in that case, I should probably do that um before or after? Probably before. So if LL that length is 0. Okay, maybe I should do it like this. Match LL L.len. So a tuple of L.len and RL.len. Okay. And then if the left is 0 and the right is some other non-zero value, then okay, so what if they're both 0? What if they're both 0? Then we return none. Oh, okay, yes. Then we return none. Return none. Okay, and then if the left is 0 but the right is not 0, then we'd return some left is smaller, so it's in the right order. So we just return some true. Oops. Otherwise, if left is non-zero but right is 0, then so this was the case in pair 7, we return some false. What's the last case? The last case is if there are elements in it, then we fucking don't do anything. Okay, great. Um, what is this? Okay, maybe I should just do this after. Enum option bool found. Shit. No, it has to be before. You want this match statement to do something. Um, I don't know. Oh, okay. I have to. Oh, this is ugly. I have to put this for loop inside of here. Oh, it's kind of nasty. What? Return a value for when the case loop has 0 elements to iterate on. Or consider changing with the return type to account for that possibility. Okay. Um, I guess we'll just return none. Okay. Yeah, this looks about right. Okay. So if you run this now, it's false. Okay, pair 8 now. It's true? What happened? What happened? Okay, let's look at this now. So let's check if we didn't make any regressions here. So true, true, false, true, true, false, true, 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 false, true, false, true, false, and okay, so this returned true somehow when it should return false. Um, what if I did this? Why did it return true? Um, okay, let's find out. VS Code, help me. Oh, it ran test. Okay, okay, run this, and then clear the editor history, and then debug. Did I break on the right line here? Nope, I did not. In fact, where's my breakpoint? Okay, breakpoint over there. Debug. Okay, so how many elements does this have? Um, okay, okay. How many elements does this have? 1, 2, 3, 4. Okay, so let's compare. Um, yeah, LV is 1, RV is 1, so should be none, so we should continue. Okay, now this is the interesting one. We have the nested lists. It says 4 and 4, but it doesn't mean that. It means two lists with it should be two lists with two elements in it, but let's step into this. Okay, so we should compare two lists. Yes, two lists. And they're non-zeros, so we should step over and um LV and RV. So it should be 2 and 2. Yes, 2 and 2. So we should return the compare again. Fuck, I should have stepped in. What did this return? Oh, okay. So somehow it compared, so there's four elements in these lists. Um, it compared the first one and then it didn't get any conclusive answer. It compared the second list, which is this nested list group, and it didn't get a conclusive answer. Then it compared the third elements, didn't get a conclusive answer, and then it went to onto the fourth elements, didn't get anything. It was like, I don't know what this was, so I'm just gonna return true. Okay. Really, what I should be doing is returning none here. I should be returning none, or some result, I think. Yeah, I should be returning some results. Or maybe none. Let's just return an option. Option boo. Option bool. Okay. And then just return none here, but otherwise return some b. And then here you have to return some. Some whatever that is. Okay. So now if we try to run this, we'll actually get a conclusive answer, which is none. Okay, but all the other ones, I believe, in fact, we can just test it right now. Everything else should be conclusive rather than the last one. Yep, some, and then none. Okay. Okay, so it's really just this last one that we need to figure out. So I need to I need to um I need to debug again. I need to run the debugging process again. I'll do it right there, and then let's clear the editor history one more time. And then let's debug. Okay, so here LV and RV are 1. Okay, we don't care about that. We care about this, which is two lists. And we'll go inside. And then now we should have eh. Did I compare 7 and no, this is 8. What? Um okay. Okay, this should be the two lists. 3 and 5? Oh my god, it's doing it again. It's comparing the first pair rather than what I actually want, which is the eighth pair. I wonder why the eighth pair went wrong. Wonder why. Okay, step over. Should get 1 and 1. Should get 2 lists now. Okay, that looks promising. Match. Okay, 2 lists. They're um they're non-zero. Okay, so now we go in. Okay, step out, step out. We went into the iter. In. Okay, we went into iter again. In. Nope. What the hell? Deref. In. Okay, iter. Okay, maybe just step over. Okay. LV and RV are 2 and 2. So they're right here. So we should expect when we return. Dude. Now it's 8. Oh my god, I need to rerun this again. I have to go in? Okay. Blah, blah, blah. 1. Okay, the 2 lists go in. Step over. Honestly, I should just continue until I go over here. Okay. Continue here. No! No. Okay, try again. Continue. Continue. Okay, here's 2. Step into. Okay. Okay, step, step. Step into. Um, what is LV and RV? Two and two. Step into. Step into. What just happened? Oh, I know what I'm doing. Oh my god. I know what I'm doing. Um, so here in compare. Okay. So here in compare, we compared 2 and 2. So we compared 2 and 2 here, which led us to go into here, 2 integers and return none. So actually I need to match this. And if we get none, um, we just continue. Otherwise, get something else, then we get some B. We return some B. Okay, this should be better. Some false. Yes. Yes. Okay. Now if we do this, she gets yeah, this looks awful, but whatever. True, true, false, true, false, true, false, false. So that should match up with what we have here. Um, so true, true, false. Yes. True, false, true. True, false, true. And then false, false. False, true, false, false. Okay, great. Okay, and now, yeah, I don't care about you. Don't care about you. So now this. Okay, so now P1 should be 13. Okay, we got option pools here. Filter B dots unwrap. Pair dot determine order. Maybe we should expect. Could not determine order of. Okay, maybe I shouldn't expect here because it would be confusing, but I should do it here. Dot expect. Could not determine order of pair u. Shit. Okay, I have to format this. A pair. And then we'll just take a reference to that. Font string, okay. Just turn this into dot two to dot aster. Yeah. Okay. You have a warning now. Okay, sure. Let's try this. Should be 13. Okay. Now let's format this so that my eyes aren't burning. And then this looks good. Okay, let's try it on the input then. $6,503. All right, does that work? No, too high. Oh God. Oh dear Lord. How do I even begin to debug this? Hmm. Okay, so how do I continue from here? Um, I think one thing I can do is hmm, one thing I can do is just get rid of this um, packet data structure. So do get rid of packet. it is unnecessary. Packet can be interpreted simply as just data, just a list of data. So it can packets, which I should probably do this, can be, or it just literally just is a, it is simply a um, data list. Okay. Um, why isn't to do highlighted? Okay, there you go. To do. And then, I mean, that's mainly it so far. I just need to also check this determine order nonsense. And then I'll have to refactor this and um mainly I transferred most of the logic over here to compare. So I'll have to look at this again as well. How many pairs are there? There's a lot. Would I have to manually check each and every one? That would be hard. That would be messed up. Um, yeah. What the hell is this ref keyword? Bind by reference during past pattern matching to make them borrow rather than move. It does not affect whether value is matched, only how it is matched. Consume all they can, which can sometimes be a problem when you don't really need the value to be moved and owned. By using the ref keyword, the value is only borrowed, not moved. Hmm. Why can't you put a reference here? Just borrow this and make it a reference. Would that be messed up? I mean, I guess how would you match the pattern? Because it's a reference, so it's actually just a pointer now. Oh, okay. So reference denotes that your pattern expects a reference to an object. Hence, reference is a part of said pattern. Ref indicates that you want a reference to an unpacked value. It is not matched against. Hmm. Oh, I think I'm doing it right here. Yeah, I don't know, I'm just stuck now. I'll probably stop working on this for now and just finish it tomorrow. I kind of want to see if it's working right for pair 8 though, which it probably is. Yeah. Yeah. I think you know, while I'm on it, I probably should just do this. Determine the order, look at how this works, and then I'll probably call it for right now. So let's run this. Some false, yep. And then editor history. And then let's try to debug this. Excuse me. Oh, why is there a breakpoint there? Let's try again. Let's go here. Debug. Okay. We are here. So left is. Oh wow, it's actually. It's a packets. Wait, what? Left is a packets. It contains an int, a list, 8 and 9. Okay, cool. Um, step. Okay, I'm not really interested in that. Okay, these are our lists, which is just wrong here. Step into. Okay, it's a list. Step, step. Oh, maybe I didn't compare. Maybe I didn't. Maybe I didn't consider the case where the lists are of different lengths. Yeah, I didn't. I didn't consider when lists are different lengths. I didn't. Okay. Let's try that. Um, okay. So here, if this didn't happen, then if um I guess we just return lv.len is smaller than rv.len, and this is sum rather than none. Sum sorry, ll.len, rl.len. What if they're the same length? What if they're the same length? Then we return none. Okay. Okay. How did I do this before? How did I do this before? If you're the same length. Um, I used compare, didn't I? Okay, so this is what we do. If uh maybe I just okay. I need this. Oink. Okay. C2R. Now compare and then match against this. Um if it's equal. We just care if it's equal. Well, okay, if it's equal, then yeah, okay. I wanted to get to avoid having to write ll.len is less than rl.len multiple times, or even just the terms ll.len and rl.len, but it seems unavoidable because in the first case I would have had to write like if ll.len is equal to rl.len, then return none, or simply none. I don't think if statements can return anything. I think just return void. But otherwise, you have to write sum ll.len is less than rl.len. Something like this instead of using compare. Oh, that works. Well, that's just easier to write. So yeah. Um. So now, okay. So this is still true. And now, what if we did inputs? Um. I mean, I don't care about this anymore. So last time we had 6503. Now we have 6483, which is less than 6503, which is what they said was wrong with my answer. It's too high. But it's too high again. Okay, this isn't right, but we're getting somewhere. Why would this ever be reached? Why would this ever be reached? Okay, one thing I want to know, can can get the debugger in Visual Studio, can it print out my packets nicely? I know I said I would give up, but I'm not giving up. I'm onto something. Okay. Debug console. P self. to pair. Okay, it does, but can I call something? Call print line. Can I call macros? I don't think I can. Um, self. No. What is this? What is debug console even? How would I call Rust macro in a debug console? Is that even possible? Would I have to do unsavory things like store string representation of the packet and or pair inside of the packet itself? That would be very unsavory and unpleasant. Um, I don't know. Yeah, I have no idea. Okay, well, that was my one go at it. Oh, what the hell? I'll try this again later. You know what? For debugging, oh my God, why am I still on this? Holy, I'm addicted. For debugging, maybe I could use some print statements, some well-placed print statements. Okay, but that's for tomorrow. It's a little too much work. Or is it? Printf, print line. What the hell am I doing? Print line, compare, merp, versus merp, and then this would be li_ri. Then here I would do compare, oh, print line, compare, merp, versus merp, and then this would be self and other. Am I moving shit? No? Okay, great. And then that should be enough to tell me what's happening, right? Let's do this. Print line. Uh, pair this. And then I+1. And then maybe we can try running. Um, here, pair, print line. Compare, um, compare versus LV, RV. What? Why my print line statement's not coming out? Okay, maybe this left versus right. Oops. Maybe add another print line so that I can see. Okay, just add it here. Why isn't it printing? Why isn't it printing? What? Uh, maybe here. Maybe I have to put it there. No, no, that doesn't make sense. What? Why are my print lines? Oh, because I'm doing returns. Oh God, I hate returns now. Okay, this is easily fixed with a well-placed new line. Okay, great. Nothing is returning, so none of these print lines are uh being run. So this is an elements of two lists, or this is a packet of two lists. This is a packet of three lists. And then what was the results? I don't know. Yeah, this is something to do later. Yep, I'm giving up. All right. Peace.